Hi guys, welcome back to Set Course with Tanya. Today we'll be discussing the part 2 of measurement of elements, a topic under general navigation, that is point of safe return or the PSR. So let's get started. Well, point of safe return, which is also referred as the point of no return or the radius of action, it is actually the furthermost point for which an aeroplane can return back to its departure safely using all the fuel available but excluding the safety reserve. So it is that point for which an aeroplane can return to its, say, departure airfield or the departure alternate within the safe endurance of that particular aircraft. With this definition, we got to know that point of safe return is actually a distance based and an endurance based subject. Now, since we have used this word endurance so many times, what actually the endurance mean? Now, endurance is actually of two types. Total endurance, the time for which an aircraft can remain airborne, at the end of which all tanks are empty. So the total time that an aeroplane can fly using or consuming all of the tanks is the total endurance. However, safe endurance is that particular time for which an aeroplane can remain airborne but it is not using the safety reserve or the mandatory reserve of the fuel that is required to be overhead the departure airfield or the alternate is still there with the aircraft. Mathematically, it is the sum of the time out to PSR and the time home to PSR. That is, it is the sum of the time, say T1, which is required for an aircraft from going to departure to the point of safe return, and the time it need or it takes to come back to the departure airfield. Now, when do we actually calculate a PSR? If the weather, the runway condition, the nav aids, or any condition at the destination, it is likely to deteriorate, and the only recourse is to return back to our departure airfield or the alternate. It is important to calculate a PSR. Moreover, in flight, at a reasonable time before the ETA for the PSR is coming, the pilot checks that the destination airfield weather and the landing aids are acceptable for a period of usually 1 hour before and 1 hour after the ETA to destination, so that in case of any emergency, the pilot can take a readily available decision to either return to the departure or, for that matter, the departure alternate in cases when there is no diversion available. Now, how to calculate the distance and time to reach such a point? Now, let's take our departure airfield as A, our destination as B, and point P as the point of safe return or point of no return. We know that the distance D, say from A to P, is going to remain same from P to A. Now let's take the time T as the time for an aircraft to go from A to P. And let's take our ground speed as O. So our time T as time from A to P, and O is our ground speed out again from A to P. Let's take our safe endurance as E. Now, by the definition of safe endurance, we were aware that it is the sum of the time from A to P and from P to A. So, if the time from A to P is T, the time from P to A is going to be E minus T. And let's take the speed as h, our ground speed from P to A. Now the distance is going to remain same, so distance out is going to remain distance home, which is our A to P and P to A. By definition, we know that speed is equals to distance over time. So distance is equals to speed into time. Now in this case, speed O into T equals h into E minus T. Solving this equation, we get time equals he O plus h. This is our time to reach point of safe return. Now we know that distance is equals to speed cross time, so we can calculate the distance as O into T, which is EOH divided O plus H. This is our distance to reach point of safe return. Now let's discuss the factors affecting PSR with some numericals. The first one being winds, and the case one of which is nil winds. Now we have a question that what is the distance to point of safe return if an aircraft has a TAS of 300 knots and a safe endurance of 10 hours. In this case, no winds are being mentioned, so this is a case of nil wind. Now let's draw the diagram. We are asked to calculate the distance to our point of safe return, which is like P. From say A, we have our endurance as 10 hours, TAS as 300 knots. Now distance say D, which is going to remain same. So by equation, we have the time from A to P as T. The other time would be 10 minus T, which is endurance minus time. And the first speed is 300. So it's 300 T equals 300 10 minus T. Solving this equation, we have T as 5 hours. Since we are asked about our distance, so distance equals 300 T, which is 300 into 5, which is 1500 nautical miles. So in case of nil winds, we found that our distance is 1500 nautical miles. How about in the same question we add some winds? Let's consider that we have a head wind of 50 knots and all the data remains same. That is our TAS as 300 knots and our endurance as 10 hours. So again, let's draw the figure from A to our point of safe return, which is P. So our time to reach as T. And because we are receiving a headwind, our speed now becomes 300 minus 50, which is 250 knots. On the way back, our time would be our endurance minus time. And this headwind now becomes a tailwind. So we have our TAS as 350 knots. our ground speed as 350 knots. Now the distance is same, d1 equals d2 and distance is equals to speed into time. So 250 into t equals 350 into 10 minus t. Solving the equation, we have t as 5.83 hours. Now our distance would be 250 cross t, which comes out around 1458.33 nautical miles. So earlier we saw that in case of nil winds, our distance was 1500 nautical miles. And if we are receiving our headwind, our distance come 1458.33. So our distance has decreased. Now I would want you to try it yourself, the case of tailwind, a tailwind of 50 knots, and what does the distance come? Does it increase or decrease? So summarizing what we discussed, in case of nil winds, with the same data for speed and endurance, our distance was 1500 nautical miles. In case of headwind, it came around 1458.33. And in case of a tailwind, it is same as 1458.33 nautical miles. So we can conclude that the distance to the point of safe return is going to be maximum in case of nil wind. And for headwind or tailwind, the distance is going to reduce. Now let's look at the other factor. Now fuel consumption is actually our fuel over time. And if fuel consumption is going to be lower, our endurance, that is the tendency to be airborne, is going to increase. And since the endurance is increasing, our distance to PSR will also increase, since PSR is a endurance dependent concept. Now let's wind up this concept with one last numerical. We are asked that what is the distance from Q to the point of safe return for an aircraft that was over Q at 1320 hours flying direct to R, given the following data. Let's draw the figure Q. We are at Q at 1320 hours and we are flying direct to R. And we have to calculate the distance to our point of safe return. Let's refer it as P. The distance Q to R is 3016 nautical miles. Our TAS is 480. Endurance as 10 hours. Wind component outbound is minus 90 knot. So our ground speed outbound would be 480 minus 90, which comes out 390 knots. And the mean wind component homebound is plus 75 knots. So ground speed home is 480 plus 75, which is 555 knots. Now we know that distance is equal, so d1 equals d2, d1 from Q to P and d2 P to Q. Distance equals speed into time, so our outbound speed 390 into time, say t, equals our homebound ground speed 555 into our time home, which is 10 minus t, the endurance minus the time outbound. So solving this equation, we have t as 5.87 hours. And our distance would be 3990 cross t, which comes out around 2290 nautical miles, which is our final answer. So this was all regarding the point of safe return, the PSR, or the point of no return, the PNR. The most important thing to remember in this entire concept is that safe endurance. It is actually the sum of time from our departure to the point of safe return plus the time from point of safe return to our departure airfield back, or the departure alternate. So thanks for watching. If you face any difficulty in understanding the concept, just let me know in the comment section and I'll be more than happy to help you.